In this video, I will talk about the scalar product. This is also known as a dot product. Consider first, we have vector A, something like this, and we have a vector B, something like this. Between them, the angle is given by theta. Let's call it this angle theta. Now, what the scalar and the dot product means, actually we take this the projection of A to this B. This is a projection. This red color arrow is a projection. You can consider, you have a light source that shine toward this A, and then they will form uh, the shadow on this vector B. Right now, the dot product actually means that we take this projection, we again multiply with the vector B. This is a vector B. We multiply this with this the projection of A. Now, how we mathematically find out this expression? First, let me redraw this triangle. So here, something like this. This is right. It's the angle theta. Let's call this the hypotenuse to be A, and this is AY for the uh, opposite opposite, and this the adjacent to be AX. Right now, on trigonometry, we know the cos theta is definition is given by the adjacent divided by the hypotenuse. Right, in this case, our adjacent is just AX and over the A. Right now, we multiply this A at the both sides, we get the AX is just equals to A cos theta. Right, so this is a projection. Right, you can see, compare these two. This is actually just AX. Right, now remember the definition I told you. This A dot B is just the projection of a one vector. In this case is AX, multiply with the another vector, which in this case is B. Now we substitute this thing inside this equation, we get AB cos theta. Right, usually we will just take this A and B as an absolute magnitude, absolute value. That means we just take the value, we not consider the positive and negative, that kind of thing, because they were taken by this angle theta. Later you will see the example on this. Now, you might feel a bit strange why we need to define the thing, the projection of the arrow and then multiply with another vector, another arrow. They have a good reason why we physics need this kind of mathematical concept. So let me give you an example. The work done is defined by the F dot S, and this F is force, and this S is displacement, or sometimes is distance. Depends on the physical case you have. So this actually is equals to Fs cos theta. Now you can see this work done involve two physical quantity. One is force, one is displacement. Right, and how this dot product come out in play? Consider the following. We have some object here. Let's say this is line A, and here we have a line B. We intended to move this object from the line A to line B. Actually, we can just apply a force, right? So the object will move toward this line B, right? But what if we apply some force, have an angle to the horizontal? And by the way, this is distance s, right? If you apply a force here, you can see the box or the object here will end up somewhere here. Is still reach point B, right? But you can see they have displacement in the y component, right? They separate between the y from the first point where we reach uh, the line B. Now, I mean, we can see here the actual contribution for this object to move from this line A to line B actually is just the uh, horizontal component, right? This y is not necessary, right? We can see this. We directly apply the force toward this line B. Without the y component, they will still reach the B. So actually, we agree on this. The y component is not necessary, right? But in this case, we have, because we have some angle data uh, to the this horizontal, and this is clearly to see if we set this angle data to be 90, and you can see the arrow was just pointing out like this, and it never reached the B, right? I think this is what we all agree on. So the only contribution is actually given by the cos data here. In this case, the 90 data equal 90 degrees. If you substitute inside this formula, you will get the work done is equals to 0, right? So this dot product allow us to separate the component that we want to reach our objective from the component we do need for it to reach our objective. So this is a reason why the physical system we need a dot product. The last key point I want to mention is that this scalar and a dot product will just give you the a magnitude. The result that you calculate, for example, you calculate this work done, they will just give you a magnitude, and this is different from the cost product, which I will explain later.